In this video, we'll be going over multiplying and dividing exponents. But before we do, let's go over our definition of exponents. We know that exponents represents repeated multiplication. So for example, if we have this here, 2 to the 4th power, this exponent of 4 tells me that I have 4 terms being multiplied together. And having a base of 2 tells me that everything that's being multiplied are all of these 2's. So 2 to the 4th power is going to be 2 times 2 times 2 times 2. Using this definition can help us multiply and divide exponents. So let's go over our first example problem. I want to simplify this expression. And when I simplify an expression, I want to write it so it has a single base and a single exponent. All right, so first 2 to the 4th power. Like we said before, this is going to be 4 of these 2's being multiplied together. Now we need to figure out what is 2 to the 2nd power. How many 2's do we have being multiplied together? 2 to the 2nd power is going to be 2 times 2. Now how can we simplify this? How can we write this with a single base and a single exponent? What expression would represent all of these 2's being multiplied together? Since I have 4 of them over here, 2 of them over here, this is actually equal to 2 to the 6th power. I have 6 of these 2's all being multiplied together. All right, so the simplified version is 2 to the 6th power. Let's go over our second example. Here I have 5 to the 3rd times 5 to the 6th. So what does 5 to the 3rd power represent? That's going to be 3 of these 5's being multiplied together. Now what would be 5 to the 6th power? That's going to be 1, 2, 3, 4, 5, 6 of these 5's being multiplied together. So how can I simplify this? How can I write this with a single base and exponent? Well, since I have 3 5's over here, 6 5's over here, I know that in total I'm multiplying 9 of these 5's together. So this is going to be 5 to the 9th power. Let's go over our third example. Here I have 4 to the 100th power times 4 to the 50th power. I know that 4 to the 100th power is going to be 4 times 4 for a total of 100 times. And I kind of don't want to write all of that out. That's going to be a lot of 4's to multiply together. So let's not write it out. But here I'm going to need you guys to use your imagination. Can you guys picture in your head that there are 100 of these 4's being multiplied together? Again, I'm not going to write it all out, but can you imagine that there's 100 of these? Good. Now, using our imagination, here we have 4 to the 50th power. How many 4's do we have being multiplied together? Again, I'm not going to write all of them out, but we have all of these 4's being multiplied, and in total there should be about 50 of them. So, if I have 100 4's over here, 50 4's over here, how can I write this as a simplified exponent? What should our exponent be to represent all of these 4's being multiplied together? Since I have 100 here, 50 here, in total that's going to be 150 4's all being multiplied together. So that's going to be our expression. All right. Now let's go over some division problems involving exponents. Just like before, we're going to start off by using our definition of exponents. So here we have 3 to the 9th power, and that's going to represent how many 3's? That's going to be 3 times 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 3. In total, we should have 9 3's multiplied together. Right? Now, how do we represent 3 to the 7th power? How many 3's do we have being multiplied together? Right? We have 7 of them. And since these are on the bottom of the fraction, we're going to write these out underneath the fraction sign. So these 3's are underneath the fraction. 3, 4, 5, 6, 7. Right? So now let's simplify. Do you remember when we have a number on top and bottom of the fraction, what happens to these numbers? When we have the same numbers on top and bottom, we can cancel them out. So these are going to cancel, these, all of these are going to cancel out. So how many 3's do we have left over being multiplied together? I know that my base is going to be 3. And since there are 2 of them left, this is 3 to the 2nd power. Okay, let's go over our next example. Here, let's go ahead and use our definition to write these out. I have 7 to the 10th power. How many 7's are being multiplied together? We're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of these 7s being multiplied together. Now, let's go ahead and write out the denominator. How many 7s do we have here? We're going to have 5 of these 7s being multiplied together. Right? And now, since we have the same number on top and bottom of a fraction, we can start canceling out. So these are going to cancel, 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 and cancel. And what's left over is going to be our answer. Right? How can we write the remaining 7s as an exponential expression? Since I have 7s being multiplied, and in total there are 5 of them, this is going to be 7 to the 5th power. All right, and now let's go over our last example. Here I have 8 to the 200th power divided by 8 to the 100th power. So 8 to the 200, how many 8s are being multiplied together? There are going to be 200 of these 8s. Again, I kind of don't want to write all of it, so I'm going to need you guys to use your imagination. Can you guys imagine? I have 200 of these 8s all on top of the fraction bar. Right? Can you guys imagine that? Okay. Now let's figure out our denominator. I have 8 to the 100th power. So again, I have 100 of these 8s being multiplied underneath my fraction. So since we have the same number on top and bottom, we can start canceling out like before. After we cancel everything on top and everything on the bottom, how many 8s will we have left over? I know that 100 of those 8s will cancel out with 100 of them on top, and so that leaves 100 of them left. So we have 8 to the 100th power. All right? So in conclusion, you guys might notice that when we multiply two exponents together, we're just adding the two exponents together. And when we divide two exponential expressions, we're subtracting the exponents.